Hi, welcome to lesson 20, constructing the unit circle. Today we are going to be talking about how to construct the unit circle, and then we are going to learn about some very nice properties of the unit circle. But before we begin, let us look at a few items we looked at in our previous lecture, lecture 19. In our previous lecture, we started talking about a right angle triangle. We said for this particular right angle triangle, its interior angles, alpha and beta, should sum up to 90 degrees. For the angle alpha, we labeled the adjacent of the triangle, the opposite, and the hypotenuse. We learned about Pythagoras theorem, which said that the length of the hypotenuse squared was equal to the length of the adjacent squared plus the length of the opposite squared. We also learned about the trigonometric functions. We learned about sine of the angle alpha, which was equal to opposite over hypotenuse, cosine of alpha, which was equal to adjacent over hypotenuse, tangent of alpha, which was equal to opposite over adjacent. We learned about the reciprocal of these trigonometric functions, and they were cosecant of alpha, which was the reciprocal of sine. So we got c over b, and then we had secant of alpha, the reciprocal of cosine, which was given by c over a, and then cotangent of alpha, the reciprocal of tangent, so equal to b over a. Now let's move on to what we want to treat today. A unit circle refers to a circle which is centered at the origin and has radius of length 1. So if we have our x and our y axis, our unit circle is going to be our unit circle is going to be a circle with its center at this point, and the length of any line from the origin to any point on the circle has length to be equal to 1. That is what the unit circle looks like, but that is just that's just looking at it on the surface. The unit circle is much more interesting and contains more information than it looks on the surface, and that is what you are going to be looking at. Over here we have a right angle triangle in the first quadrant of this Cartesian plane, and from what we did in lecture 19, we can easily label and tell and say what the interior angles are. We have that this is always 90 degrees, and if this is 45, then this particular angle has to be equal to 45 degrees as well, because the angle over here and the one over here must sum up to 90 degrees. Now, if we have this, how do we get what is going to be the length of the base of this triangle, and what is going to be the height of this triangle? In other words, what is going to be the length of the opposite of 45 degrees and the length of the adjacent of 45 degrees? We are going to take the hypotenuse to be equal to 1. Then we will have that the sine of 45 degrees is equal, like we said, to opposite over hypotenuse, which happens to be 1 over here. So In other words, our opposite is equal to sine 45 degrees. And our adjacent, cosine of 45 degrees, is equal to adjacent, which is a, over our hypotenuse, which is 1. So our adjacent is equal to cosine of 45 degrees. Now, this actually tells us that the coordinates that make up this point is equal to AB. But AB is cosine of 45 degrees and sine of 45 degrees. And over here, we have the same diagram with the unit circle drawn through our point, which we just found its coordinate to be cosine of 45 degrees, sine of 45 degrees. Now, upon reflecting this point through about the x-axis, we get another point on the unit circle, and this point is going to be cosine of 45 degrees minus sine of 45 degrees. Reflecting it about the y-axis, we get minus cosine of 45 degrees. We get this point here, and then sine of 45 degrees. And reflecting it about the origin, we get this point over here, which is minus cosine of 45 degrees and minus sine of 45 degrees. Good. Let us look at another example of this same diagram. This time we have that the right angle triangle inside the first quadrant has one of its interior angles to be 30 degrees. We know this is 90. This has to be 60 because the angle over here and the one over here must sum up to 90. Then labeling, taking the hypotenuse to be 1 and labeling the opposite of 30 degrees to be B and its adjacent to be A, we are going to have that sine of 30 degrees is going to be the opposite over the hypotenuse, and in turn get B to be equal to sine 30. Cosine of 30 degrees is equal to adjacent over hypotenuse, so that gives us A to be cosine of 30 degrees. Now this point has its coordinates to be A, B, but A, B is the same as cosine 30 sine 30. Doing exactly as we did in the previous example, we draw a unit circle that goes through this particular point, and we are able to see that once again, initially we worked with a triangle, and then we had that the coordinate the point on that triangle, let's say this is our previous triangle, we had that the point on that triangle has coordinates cosine of 45, sine of 45, and then upon reflecting it about the x-axis, the y-axis, and about the origin, we got other points which had this particular structure. Again, we found out that another point on the unit circle has coordinates cosine 30, sine 30. Reflecting it about the origin, about the x-axis, give us this point, which is cosine 30 minus sine 30. About the y-axis gives us this point, which is minus cosine 30 sine 30. About the origin gives us this point, which is minus cosine 30 minus sine 30. For another example, let us look at when we have one of our angles to be 60 degrees. Then we know this is going to be 90, and then this is going to be 30. We'll have our adjacent to 60 degrees to be our opposite to 60 degrees to be B, our adjacent to be A. Taking our hypotenuse to be of length 1, we'll definitely have that the coordinate of this point is given by AB, which is equal to cosine of 60 degrees, comma sine of 60 degrees. Then upon drawing the unit circle, we have that the point of this particular this particular point AB, or this point cosine 60 sine 60, also lies on the unit circle, and when reflected about the y-axis, the x-axis, and about the origin, we get these points. So we have here to be cosine 60 sine 60, here to be cosine 60 minus sine 60, here to be minus cosine 60 sine 60, this to be minus cosine 60 minus sine 60. So we'll in all we found 3 coordinates, 12 points on the unit circle whose coordinates are of the form plus or minus cosine of some angle alpha plus or minus sine of some angle alpha. Now, combining all the work that we have been doing for all the 3 right angle triangles we found in the first quadrant, we are able to get this particular diagram over here. So with the ones with the coordinates labeled in green, clearly that is when we had our interior angle to be 30, and then all these points are just cosine 30 degrees sine 30, and here we have cosine 30 minus sine 30. Here we have minus cosine 30 sine 30. Here we have minus cosine 30 minus sine 30. The one with the lines labeled, with the lines intersecting the points labeled red, colored red, is when we had our interior angle to be 45 degrees. So this point here is cosine 45 sine 45. Reflecting it about the x-axis, we had cosine 45 minus sine 45. About the y-axis, we had cosine minus cosine 45 sine 45, and reflecting it about the origin, we had minus cosine 45 minus sine 45. So that just remains the one with the blue lines, and that is when we had our angle, interior angle, to be 60 degrees. So this here has coordinate cosine 60 sine 60 and cosine 60 minus sine 60 this has cosine minus cosine 60 sine 60, and finally this has coordinates minus cosine 60 minus sine 60. So those are the 12 points on the circle, on the unit circle, which we have found. And like we said, they all have the form plus or minus cosine of some angle alpha plus or minus cosine sine of some angle of that same angle alpha. So this is not much different from the triangle that we just saw. It's just that everything has been changed into radians. So it's just that the values which we wrote has been evaluated, and then the angles have been changed to radians. So here we have that 30 degrees in radians is just pi over 6. If you do not recall the formula for changing your angles from degrees to radians, we said that if I had an angle alpha in degrees, then to change it to radians, I only had to multiply it by pi divided by 180. So just for a few examples, when you had 30 degrees multiplied by pi over 180, you have here that this one divided by 30 is 6, and then this divided by 30, this one divided by 30 is 1, this divided by 30 is 6. So you just get pi over 6. And then 45 degrees times pi over 180, we just get 45 here 1, 45 here 4. So we have pi over 4 radians. And then lastly, for 60 degrees, we had pi over 180, where we had pi. So 60 goes here 1, 60 goes here 3. So pi over 3 radians. Also, instead of having our coordinates written like cosine of alpha, instead of having our coordinates written as cosine plus or minus cosine of alpha, comma, plus or minus sine of alpha, over here the coordinates have been evaluated. So here for cosine of 30 sine 30, we had root 3 on 2, comma, 1 over 2. For cosine for cosine 45 sine 45, we had root 2 on 2, comma, 2 over 2, and then root 2 on 2 again. And for cosine 60 over sine 60, comma, sine 60, we had 1 over 2, comma, root 3 on 2. So it is only these 3 points that has been reflected about the y-axis, about the x-axis, and about the z-axis to get us this diagram over here. In addition to this diagram, we are going to label some other angles on the unit circle. On the x-axis, we are going to label the angle, this particular point, which coincides with the angle 0. So here we have 0 degrees. And then on the x-axis, on the y-axis, we are going to label this particular angle 90 degrees. So the 90 degrees angle coincides with our y-axis, and in radians is just pi over 2. On the other side of the x-axis, we have 180 degrees. So we plot this point as well. And lastly, on the other side of the y-axis, the downward side of the y-axis, we had 270 degrees. So all these points inside our Cartesian plane, drawing a circle through a line, a curve through all these points is what gives us our unit circle. So we have that this circle is centered at the origin and has radius 1. And the main idea of this lesson is to just drive home the point that every point on the unit circle has its form given by plus or minus cosine of some angle alpha plus or minus sine of the same angle alpha. So every point, although we did it for a few of the angles, every point on this particular circle has its coordinates to be of this form. And that was the goal of this lecture. So that will be the end of today's lecture. Thank you. Bye bye.